Hey everybody, welcome to another DevHeads Engineering Hour. I'm Brandon Lewis and I'm here with my friend Dimesh Lakonde, and today we're going to be continuing our series on Ethernet for embedded applications, focusing on the implementation of MODBUS TCP on an STM32 platform. So I know nobody likes hearing all of my jabbering about background stuff, but I got to do it to cut down on the questions in the chat that aren't related to the technical content, which is really what we're here to focus on. So I'm going to go through as much of this as I can right now. If you do have questions, please feel free to drop them in the chat channel of whatever platform you're on. It could be LinkedIn, YouTube, or here in the webinar platform Livestorm. So number one is, if you are pulling less than 5 megabits per second download speeds, you might have some trouble viewing the event. This happens occasionally, so use a tool like speedtest.net. Make sure that you've got sufficient bandwidth, and if not, try to get to a place where you have a better network. If you still can't get to a place with a better network, we are going to be recording the session, and we'll post it on our YouTube, which you can find online. The next thing is that please participate in the event. This is a community event. We'd like to have your input, your questions. Dimesh is an expert in this field. He's been doing this for a long time. Take advantage. We had a bunch of great discussion on a similar topic last time. So use the chat channel wherever you're natively watching, and me or one of our team members will grab your question and we'll either put it into the chat so that others who have experience in this area can participate in it as well, or we'll hold them to the end and we'll ask Dimesh to respond. I know he's got a bunch of content today, so we'll try to get to as many questions as we can. Keep an eye out for some resources. I already dropped one in the webinar platform that shows the stuff from last time. So the slides, the GitHub repository, and the recording are all there. If you go to our Discord community at discord.gg/devheads, you'll be able to jump in and find those, and also be able to talk to Dimesh in the digital flesh. Other than that, I think that's pretty much the rundown. If you have other specific questions, please let me know, but I don't want to take up much more time. So I'm going to hand it off to Dimesh, and he's going to jump into implementing MODBUS TCP on STM32 and W5500. Take it away, Dimesh.
Hi, everyone. I hope you're excited to learn and explore how to implement MODBUS TCP on STM32 microcontroller. And we will be using W5500 Ethernet 5 from Wisnet to implement this. So before we go and do the presentation, I want to show you something what we will be implementing today. Okay, what's the objective? So you see on my screen here, it's a simply Modbus TCP client. And because we will be using this Modbus TCP concept a lot, so we will be communicating TCP client and server communication. So this simply Modbus is a TCP client application, and this is what we will be connecting to the hardware. Let me show you the real physical hardware. So here's a real physical hardware, and this STM32 microcontroller will be running the Modbus TCP server using this W5500 Ethernet 5 chip from the Wisnet. And what we will be doing is we will be using this simply Modbus TCP client, and this client will then gonna talk to the server running onto the microcontroller. Let me show you what we want to achieve. So basically, over this client and server communication, we want to achieve two goals. One is to control the device, and you can see here we have an LED. I have this red LED here that we will be controlling, and then there will be a message that will be stored into the holding register. If you don't understand everything, that's absolutely fine. Hold on for a minute and you will get to know this. So we will be reading the data from the microcontroller, because this microcontroller will be acting as a TCP server, and this simply Modbus will be a TCP client for us. So let me just disconnect first, and this client will be connecting to this hardware setup, which is running TCP server. Let me click on connect button. You can see it is connected now, and you can see there are a couple of addresses. Let me just show you a quick magic here. I can click on this right button because I want to send the message from this simply Modbus TCP client to the server, which is our microcontroller. So the register address that we have to put for the coils is 1, and the value that I have to write is again 1. Just hold on. Okay, let me click on send button, and this will send this value 1 to this hardware STM32 microcontroller. Let me click on send button. You see the LED turn it on, right? So LED lights up. Now, if I change the value to right, let me just write 0 and click on send button. So it will send the request from the Modbus TCP client, and you see the LED goes off, right? So this is the first goal that we have to achieve to control the device. Let me show you how you monitor the device, okay? So as I said, this STM32 microcontroller has a message in it. We want to read into this simply Modbus TCP client. And what I'm going to do is I will just put the address. This register is same. The address is same. This want to read the message. Let's say 10 registers I want to read. And I click on send button. You see here, there are only 2 rows. And when I put 10 numbers, so it will read the 10 registers. And then I click on send, and you see this bytes came from the microcontroller. So what is happening is this Modbus TCP client is reading data from this microcontroller. And what this message is all about, by the way, this is very typical hello world message. I'm going to decode this in the future and going to show you. I hope by now this is clear what we want to achieve. Okay, so let's go to presentation and put things in perspective to make the sense out of everything that we have seen as a demo. So we're going to start off with an overview of Modbus TCP IP. So build the foundation. Then we will be talking about 7 layers into the OSI model. Then we will get into the Modbus networking layer. There are 4 layers. And then we will talk about the Modbus TCP data frame, because it's very important when we are learning about the Modbus TCP protocol. We have to understand the data frame format. Then I will show you how to use this simply Modbus TCP client to work with this Modbus TCP project. And then we will implement the live demo where we will implement Modbus TCP on STM32 using W5500 module. And then we'll summarize all the things that we have seen so far. Basically, we will compare Modbus RTU and Modbus TCP that we have seen today. And towards the end of the session, I will take a question if you have any. In case if we run out of time, then feel free to drop your question into the Discord server. So Modbus TCP IP, okay, it's an application layer messaging protocol. That means this protocol Modbus TCP works on the application layer. The messaging structure is a command and response over TCP port 502. So the reason I said command and response, the way you can understand is request and response. I want to be technically correct. That's why I use this word command and response. So you write a command to the Modbus server, and then server will respond as a request, a response. So you can either call it as a command and response, or you can call it as a request and response, whatever you prefer to technically correct. It's better to call it command and response. It will happen over TCP port 502, which is a standard Modbus port. Now, Modbus TCP works with an Ethernet to enable client and server communication. It's because if you have seen our previous live stream where we talk about Modbus RTU, the communication between 2 devices happens as a master and slave. Okay, so when we are using Modbus RTU, the communication is a master and slave. But when we are dealing with a Modbus TCP, the communication will be a client and server, because we use an Ethernet, and Ethernet enable us to do that. Now, this Modbus TCP leverage TCP IP protocol stack commonly used in Ethernet networking. That's why many or almost any product that you see Modbus TCP enable uses Ethernet. And that's why Ethernet is really a foundation and building block for industrial automation or IIoT or Industry 4.0 solutions. Now, the Modbus TCP IP is universally supported from PLCs to HMIs to gateways, sensor nodes. Even you will find it on the edge devices, right? So when it comes to industrial automation, you will find it, the Modbus TCP IP, almost on every product, every solution. So let's just talk about the OSI model. There are 7 layers into the OSI model. So any device that connects to internet, of course, that device sends the data back and forth, client and server. and this data flows through the layers, right? So on very top, whenever any data sent over internet, it will be on the application layer. On the top you have an application layer. Think your application layer as your browser, right, to open a web client, or you can consider as a email box as a SMTP protocol. It uses SMTP. Similarly, we will be using Modbus protocol on the application layer here, and on very bottom we will be using a physical layer. So there are 7 layers. We don't need to go into all of them, but how the data flows, that's what I wanted to show you. Whenever you want to send a data from the server, you will send it from the applications to your application layer to your physical layer, which is your actual physical hardware. That's an Ethernet. When you want to send data to the client, then your physical hardware, that is an Ethernet hub on the hardware, then we'll be sending it to the application layer. That's how your data will be sent over internet. Now, when we use Modbus TCP, let's just talk about Modbus networking layer. We are not using all 7 layers of an OSI model. Okay, so whenever we are using TCP IP, then we are using only 4 layers. So in this picture, you can see there's a client and there's a server. And on a client side, we have a 4 layers. On the top application layer, we have a Modbus software module. The point that I want to make here is whenever we are dealing with Modbus TCP as a protocol, remember always the Modbus TCP sits into the application layer. Many people use the protocol, but they don't know where exactly into the TCP IP stack the Modbus fits into. So always remember your Modbus TCP will be at the application layer, and on very bottom data link layer will be connected over Ethernet to your server. And client and server communication is the same. The point here is whenever we use Modbus TCP, we use a 4 layers, and on the top, on the application layer, we will be using Modbus TCP, and on at the hardware end of the protocol we will be using Ethernet. That's why all of the use cases where we are implementing Modbus TCP, we use an Ethernet as a communication medium for an internet connectivity. I hope this makes sense. So this is called Modbus networking layer. There are 4 layers, and as like in a previous slide you might have seen, I have shown you a 7 layer OSI model. So in the normal communication you can use the 7 layers, but in the Modbus TCP you just need a 4 layers, and that is what it is. Now let's just talk about the Modbus TCP data frame, and you can see the frame of a Modbus TCP starts with a transaction identifier. Then we have to send the protocol identifier, then there's a length, there's a unit ID, function code, and the 8-bit data byte. Now you will say, okay, you can read this. The reason I am explaining this way is because this is the frame in which we format our data and send a frame from our client to server or from server to client. Okay. Now, this Modbus frame is made up of something called a protocol data unit, PDU, and something called MBAP. Okay, MBAP is the Modbus application protocol header. The way this slide is structured is because I want to make one point here. So whenever we talk about Modbus RTU frame, then Modbus RTU frame is composed of unit ID, function code, and the data byte. The difference happens when we talk about Modbus TCP. We put this 6 bytes on the top of unit ID. This unit ID is same as a slave ID. In Modbus RTU, we refer unit ID as a slave ID, but it's the same thing. It's just a 1 byte of data. So transaction identifier. What is transaction identifier? As we talked about, the communication of a Modbus happens in a request and response. Every time you send the data from one device to other device, you send a request, right? And that request is referred it as a transaction. Okay, so you send one request, your transaction identifier is 1. You send the second request to request the second data from the hardware, it would be number 2, 3, 4, 5. As many requests as you send transaction identifier, this value will increment. Then protocol identifier. When you send the packet, this packet from a client to server or server to client, how this frame will be understood as a Modbus frame, because we put the protocol identifier, which is usually a 00 in all the cases. And 00 is basically to define as a Modbus service, right? And then we define the length, how many bytes that we want to send, then unit ID, which slave device, which exact ID, because there will be a multiple Modbus devices. Okay, so how can you write to a particular Modbus device? And that is what defined by a unit ID, which is also referred it as a slave ID in case of Modbus RTU. And then we put the function code. Function code is basically a number. We'll get into that. It defines whether we want to write or we want to read. So function code defines the action that we want to take, right? Whether we want to send or receive, where we want to send, right? Which address we want to write. So that is the function code. And then the 8-bit data byte. So that's basically a data that you are sending. So we'll get into that. But just remember, you have this Modbus TCP data frame made up of MBAP, okay, MBAP header plus protocol data unit. So if you put the MBAP header plus protocol data unit is the same as the Modbus RTU, right? If you combine, you get what? You get a Modbus TCP frame, okay? This is the same Modbus TCP frame we will be coding into our microcontroller firmware. Hold on to it. So let's just get into the Modbus memory areas. I hope you remember that I said Modbus as a protocol, Modbus TCP is defined at the application layer. That means whenever we make any device Modbus compatible, that means we are putting this memory addresses into that device. Okay, so any device which is a Modbus TCP compatible or Modbus compatible, it will have a something called coils. Okay, so there are Modbus memory areas. So some memory areas will be defined as a coils. Some is defined as discrete inputs, call it inputs, then input register and holding register. Don't worry, I will explain this, what it is. Now, coils is the specific part of the Modbus memory area which define a discrete output. It's just a 1 bit. So when somebody says, I want to write a coil, that means they want to write 1 bit of data. And you use a coils when you want to control a device. Let's say you want to control a wall, or you want to control the actuator, right? Or you want to activate the relay. So something like, in our case, we will be controlling this LED, right? To control this LED has to be assigned. I mean, we will make the LED to work with a coil, right? Because it's a discrete output. LED is an output device, right? So coil is basically just a 1 bit. It helps us to control the device. Then inputs, which is a discrete input, again 1 bit. If you want to read the status of a switch, so let's say in a plant you want to read whether the switch is on or off, you will use the discrete inputs. Then input register, which is a 16-bit, 2 bytes. This will be used when you want to store a sensor data. You will use maybe some flow transmitter, pressure transmitter, or something in the field devices. You collect the data from the sensors, and then you can store it into the input register. Holding registers is basically an analog output, which is again 16-bit in size, so 2 bytes of data. And this will be used to control the devices like a VFD. Now, I know this is too much, but just remember 2 things: coils and holding inputs. Coils we will be using in our project to control the LED. So remember, when you want to control something, you will use a coils. And when you want to read the data from the Modbus device, Modbus compatible device, then you store into the holding register and then you read. There are 2 things in the world of embedded. What you do in embedded, you write and read from the device, right? That's what is called embedded in short. Okay, so just focus on coils and holding register. Now, the coils, whenever you make certain device as a Modbus compatible, then the coils will have a special address that is starts from 1 to 10,000. So when you assign a memory into the device, it will be a very specific starts from 1 to 10,000. Now, when it's a discrete inputs, your memory address start from 10,001 to 20,000. When it's an input register, your address starts 30,001 to 40,000. And for holding registers, the memory address 40,001 to 50,000. These addresses are fixed as per the Modbus specifications, right? So it doesn't matter whether it's a Modbus RTU or Modbus TCP, this address, okay, remains the same. So for us into this project, we only care for the coils, and we will be using the address 1. On this address 1, if we write a value 1, that means we are saying we will write the value 1 onto the coil 1, and that will turn on the LED. Okay. And in holding register 40,001 to 50,000, so this is the address in which we store the value. So let's say if we want to write a text string, hello world, the most famous text on a planet Earth. So if we store hello world string then into the holding register, that means that hello world will be stored from 40,001 to 50,000. These are the address. Forget about this inputs and input registers for now. Just focus on our project where we will be focusing on coils and holding register. So coil address starts with 1 and the holding register starts with address 40,001. We will come back to the slides a bit later when we do actual hands-on, right? But I just wanted to make this point that this memory addresses are very, very important. Now let's just talk about function code, because if you remember in the Modbus TCP frame format, I talked about something called function codes. Now there are a lot of different function codes, right? You can see in the list here. So first, we're going to talk about what is function code. Function code is a number. It's a code which define what action we want to take. So say, for example, let's take function code 5. Okay, so if we set in our Modbus frame function code 5, that means we want to write single coil, right? So if we want to control the LED connected to STM32 microcontroller, we will write a data value 1 onto a coil which is of the function code 5, right? So that's how we will write the data to the Modbus device. Now to read the data from the Modbus TCP device, we will use a function code 3. Look at this function code 3. What it does, it allows us to read the data from holding register. So in this holding register, when we use a function code 3, we read the data from the holding register, and in this holding register we have hold or store hello world string. That is how we will be reading the data. Now to write the data to control the LED, we will use the function code 5. There are only 2 function codes that we will be dealing with today, because this Modbus TCP is very huge and big topic, right? And we have to focus on what we want to achieve. So the function code 5 is allow us to write a single coil, and function code 3 allow us to read the holding registers. Remember this, when we will do a coding, this will come back to us. Now let's just talk about the connection. As I said, we will be using this W5500 Ethernet 5 chip to provide the Ethernet connectivity to our STM32 microcontroller, and we will be using an STM32 F303 Nucleo 32 board. So this STM32 microcontroller with this W5500 allow us to host the Modbus TCP server onto this microcontroller. And we will connect an LED connected to PB0 pin. So remember I said whenever we talk about coils, that coils will be associated with this LED. So when we write a value 1, the LED lights up. That's the use of the LED. And for holding register, we will use the memory of this STM32 microcontroller, which we then can able to read it from this simply Modbus client. You see on a computer, I have this simply Modbus TCP client. This is just a piece of software we will be using as a client. And what we will do is through this simply Modbus TCP client, we will send the request to our Modbus server, Modbus TCP server, which is our STM32 microcontroller with this Ethernet PHY. So when the request will be received to this microcontroller, the microcontroller will write the value 1 onto the coils, and then LED lights up, right? And obviously the message will be sent it back to the client again as a response. Now, when we want to read the data from the TCP server, Modbus TCP server on to the STM32. Then again, this simply Modbus client will send the request. It will read the data from the holding register, that's our hello world string, and the response will be sent it back to our simply Modbus TCP client. And then we can read, I will decode the message later. I will show you everything in more details, but this is what we want to set up as an hardware setup. So on the hardware side, we have this W5500 Ethernet 5 chip with a module connected to nuclear board. And then on the software side, we will be using this Modbus TCP client, simply Modbus, right? And as far as the connection goes for this W5500 module, we will be using this a standard SPI SPI communication protocol. So the meso pin will connect to PA6 pin, MOSI pin will connect to the PA7 pin on the nuclear board. Then the serial clock will connect to PA5. Chip select will connect to PA4, reset will connect to PA0, and LED is connected to PB0. So these are same pin connections that I have used in my code. So when you download the code from the devs GitHub repository and try and test at your end, make sure this connection has to be correct. Now, to learn more about this W5500 Ethernet 5 chip, including connections and hosting the TCP client and server communication, in the previous live stream, we already have it available onto the DevEd's YouTube channel. There's a detailed video about Ethernet controller W5500 module interfacing with STM32 microcontroller. So I would suggest to have a look into that video. It would help you understand things in much detail, especially about this Ethernet 5. So this is the setup that we will be following today for our project. Now, let's just talk about the client Modbus TCP client that we will be using, and it's a simply Modbus. So remember when you compare this Modbus TCP client with Modbus RTU client. So look at this, the mode we select as a TCP because Modbus we are using on the TCP. And then we want this client to connect to the server, and the server is our STM32 microcontroller. So this STM32 microcontroller is hosting a server, and this TCP server, Modbus TCP server, has this fixed IP address, static IP address assigned by us. That is what you will see in our previous live stream. I have explained how to build your own network. So this is an IP address to the server that we want to connect to, this client. And this 502 is the port Modbus TCP port number. This is a fixed port number that we have to put, and then we can click on connect, and then this client, this Modbus, simply Modbus TCP client, then can able to talk to a Modbus TCP server running on our STM32 microcontroller, a nuclear board, right? I hope this makes sense. Now, if you want to download this simply Modbus TCP client, then you can go to this website, simplymodbus.ca/TCP client, or just search on a Google, download simply Modbus, and then you can get the installer. One thing though you have to note is that this software that we are using, simply Modbus, is a demo version, right? It's a full functionality that we can access, but the limitation is we can only send a 6 request from this Modbus TCP client. So when you done sending 6 requests, you have to close this application and reopen again and connect and then try and test again, right? So usually when we build a product, we have our own Modbus client. I'm using this for the session because you can download from anywhere on a planet, and it's fairly intuitive. You have a beautiful dialog box you can use, and I will show you how to use the software. So this is what I wanted to show you. Now let's just talk about the project structure. Before we go onto the actual project, I want to show you something. So I have created this project called Modbus TCP slave. Okay, you can call it as a slave or server. It's better to technically correct, you can call it as a server, but I named the project as the Modbus TCP slave because I used the same Modbus TCP Modbus stack that we have used in our previous Modbus RTU uh, live stream episodes. So what I have done here in the project, while we are writing a program for STM32 to make the Modbus TCP server, we are using the IO library from the Viznet. that is for W5500. If you don't know IO library, go ahead and watch our previous live stream. It's about Ethernet controller, and I have gone in more detail how to integrate this IO library into your STM32 project and how you can create a TCP client and server. The new thing here today is I have integrated this Modbus stack. You can see this folder added into the project pan, Modbus, and I have written this files, which is basically a Modbus firmware, Modbus drivers, right? So let's go to project and see things in action. So let me open Cube IDE, and you see this project in a project pan, Modbus TCP slave. This is the project, and by default, it has opened this main.c file. Let me just show you when I expand IO library, you can see we are using this WizNet Ethernet specific API from the WizNet. Then this is the new Modbus integration. By the way, this code is free. My entire implementation of Modbus TCP is free to download from the devheads GitHub repository, and you can download and then you can play around it. So there are few files that I have created here. Few means there's a lot, because as I said, Modbus TCP is very huge, big topic, and it's in itself is a technology. So we are using this API from this files. I'm not going to explain everything into the file, but we'll get into that bit later. Now just focus on the core logic. And in any microcontroller project, the core logic, basically initialization and all, will be kept into the main.c file. So just focus on the main.c file, because you can trust me that by adding this IO library to this hardware, we have added Ethernet connectivity. Without having Ethernet connectivity to this STM32 microcontroller, we cannot able to put the Modbus TCP stack, right? Modbus TCP stack. For Modbus RTU, you can use a serial protocol, but for Modbus TCP, you need an Ethernet. So for Ethernet connectivity, we are using this IO library from WizNet. So by integrating this IO library drivers, we are giving the Ethernet connectivity, and by adding this Modbus drivers, we are giving the Modbus connectivity. Now just focus on the core logic. So these are just a few includes that coming from the drivers. And if you remember from our previous live stream, we will be creating a static server, Modbus TCP server with an address, IP address 192.168.2.99. And I explained, please go and refer the previous session. So, but here we are creating a small simple network between client and server. So the client will be a simply Modbus software, and the server will be an STM32 with W5500 Ethernet 5 chip. So here we are creating a small network. Then, as I said, Modbus TCP port is fixed 502. So this is a standard Modbus port. So we are giving the port. Then, as I explained, this printf function is for me to serially debug the application. And the interesting part, let me show you. So this is our Modbus client, right? Simply Modbus. Let me just open CoolTerm, which is a serial client. We'll get into code, okay? Let me just try to put things in perspective. So here we have a serial client. Let me just make something that make a sense. Options, we have to set the serial port with correct baud rate. And click on OK and connect. So this part is a hardware, right? I connect this CoolTerm, which is a serial client, and nothing shows up. That's okay, because we did not send any request from the client. So this is, this simply Modbus, you can treat it as a client, and this serial terminal, you can treat it as a TCP server, right? Let me show you. So when I send, so this is a Modbus frame, okay? So when we send the Modbus frame, you see it receive on the hardware side. The same frame is received here. Can you see? So this is a client and server communication. Okay. Now, what is this data point and all? We'll get into that bit later. Okay, it's not important. Just wanted to show you for debugging how the serial communication is useful, and I'm using it because I implemented this printf function. Okay, this project is a bit complex. Okay, so please refer our previous two live streams. Maybe link will be found into the description. But this everything is explained there. I have already explained what is this functions is all about and how to implement it. This is basically a W5500 WIZnet chip specific functions to implement the Ethernet connectivity, even including this callback functions. So I'm not going to waste your time and my time there. Just jump straight into the core logic. And the core logic, after all the initialization, which is what done by the cube IDE for us, we are creating this test string and we are storing this string hello world. I took this string hello world because it's easy for people to decode. As a programmer, you are comfortable with converting the hex value into the ASCII and all this other binary conversions. But we are creating here an array test string and we are storing this hello world, and this string test string we want to store into the holding register. Let me take you something really very important. Remember this slide, right? And the holding register starts with 40,001 to 50,000. So what we are saying here is this hello world will be stored into the holding register. That's the goal why we are creating this string. Now, we call this function called init modbus slave data. And so this is basically initialize our STM32 to act as a modbus TCP server. And we pass this object here, then we pass the slave ID. If you go to slave ID, let me just right click and go, and you can see config.h. It's a configuration. Every Modbus device into the multiple devices into the Modbus network will have a unique slave ID, right? So here in this case, our STM32 has a slave ID 1. Okay, and then you can see I have defined the number of holding register 24, number of input register coils, and this is just a variable declaration, right? So and then you can see when I call this API init modbus slave data, then we have to pass the object modbus object, that's our STM32 microcontroller specific, the structure that we created, and then we have to pass the slave ID, then the holding registers and all. So this basically initialize the modbus TCP implementation from our drivers to this STM32 microcontroller. And then we say write data to holding register, because we want to write the data. What data? This hello world string, right? So look at this test string that we want to write to which address? 40,001. Can you see 40,001? So what we are doing is we are hard coded string. We are writing the hard coded string hello world onto the holding registers, and holding register is a part of the Modbus memory area, right? So we store hello world test string onto this 40,001 address, right? Let me just show you the live demo, like only this part. I don't want to take so much and then to confuse everyone. So look at now, just focus on the holding register. We upload the code onto the microcontroller, and if you don't trust me, let me just compile. Let's build the code. Same code will be built here. So 0 error, 0 warning. Let me just click on run button, and this code will be uploading, and 0 error, 0 warning. So now the code is uploaded, right? It's still uploading. I think it's done now. The code upload is done, and now you see, because we freshly uploaded the code, it says WIZnet function registered, and then something you can read. It's plain English. The Modbus TCP server listening to on port 502, right? So the server, the STM32 is acting as a Modbus TCP server. Now let me just disconnect, okay, for a moment. Disconnect, and let me click on connect again. So the client sent to the server, Modbus TCP client is connected. Perfect. So the fresh new firmware is running, and we are focusing on this part of the code wherein we are writing this test string hello world onto this address 40,001. That's the Modbus address to read the data from the device, okay, onto our client software. That's the simply Modbus. Look at this. This is very, very important. The slave ID is 1, right? Remember in the code config.h file, the slave ID is 1. The Modbus address, holding register address, is 40,001 that we want to read. And how many bytes we want to read? Let me show you something that nobody shows. So let me put 2 here. You see, when I put 2 instead of 10, there are only 2 rows, right? And look at this request frame, okay? And it says we are interested sending 2 bytes, 2 registers, right? So of course, if we want to send the text string hello world, it's more than 2 characters, right? It's a common sense. So what we're going to do is we will take 10 register. We will read 10 register, and 10 register from 40,001. Okay, let me just click. So 40,001, this is the first register where H will be stored, HELLO, towards the 40,010. I mean, it's too much, but I hope you get the point. Like, we are reading a multiple addresses because our goal is to learn how to read the data from the Modbus TCP device. Now, how this correlate to the real world in a factory automation? You might want to write the code where you want to read the data from the holding register, and on the holding register you might have stored the value which you have configured your variable frequency drive, or maybe some value coming out of some configuration bits or something that you want to read. So reading and writing, as I said, in embedded, you read the data and you write the data, right? So let let me just explain you this frame, because that is the real implementation of the protocol. So 0003. So this 03 is because it's a, you remember our Modbus TCP frame starts with a transaction identifier. So this is a, because from the time I started this live stream, I click so many times the send button, and every time I press the send button, I'm sending a request. So this is the third request, right? And then this is a protocol identifier, 2 bytes. If you watch, revisit this live stream again onto the DevEds YouTube channel, then please note it down on a piece of paper, white piece of paper, and then correlate, and then it will make a sense. So first 2 bytes are the transaction identifier, second 2 bytes are the protocol identifier, and they remain 0 because it's a Modbus service. Then 0006, 06 because we are writing 6 bytes of data. Okay, how 6 bytes? Look at this. 1, 2, 3, 4, 5, 6. Because we want to send the 6 bytes, we have to put the 6 bytes, the length that we want to send from the client to the server. Okay, and this 0A, if you convert into decimal, it's like a 10, right? So 10, because we took the number of registered 10, it's a 10. So if I make it 2, look, this 0A will change to 02, right? Because we are reading only 2 holding registers. We need to read 10 holding registers, right? Believe me, this is very, very detailed because we are breaking down entire frame. Okay, so this is the Modbus TCP frame, which is called request. Remember first slide, Modbus TCP request and response on port 502 using the TCP, right? That's exactly what we configure into this Modbus TCP client. Now let me click on send button, so it will send the fresh new request. Bam. Look at this. The same frame that we sent as a request from the client will be received onto the server here. Okay, it says we received 12 bytes. Now look at this one. Focus here. The bytes, these are the bytes that we read, right? I cannot select on my laptop, but you can see this hexadecimal number. Now this is a request that we sent. Okay, and this is the response we receive from the Modbus hardware. That means this STM32 microcontroller. Okay, I hope this makes sense. Now let's decode what we receive. So I copy from 48. It's not because I'm just bluffing in the air. Just look at this one, 40,001. This is the first address, holding register address. Look at this one. The holding register where we stored hello world 40,001. This is the exact address we used in our simply Modbus TCP client. So it starts with 48. So let me copy 48 and I copy till this 21. Let me just right click. Okay. Right click, copy the data. I hope this copy properly. Let me go back and hex to ASCII converter. And here is the online converter I will be using. So let me put the value. Oh, it did not copy properly. Let me go back to the simply Modbus and let me copy again. So I press from keyboard Control C and then I go to this online converter. You can see here is the request. Oh, sorry, the response that we receive, the text string. And let me click on convert and you see the exact hello world that we read from the Modbus TCP server, right? We received it on the client side. I hope this is clear and this makes sense. Like we read the data from the Modbus TCP server. We don't have too much time, but let's go back to the code. So this is the logic of reading data from, and there's a lot of things, by the way, guys. Like there, if you look at this function, it is implemented into the modbus.c file, and this is basically to extract every bytes. You can review this code when you get the code and the project files from the dev's GitHub repository. And let me go back here. Let's just focus on something. This is all the Ethernet connection because we are running out of time. I think there's very little time that we have. So this is all implementation of the transaction ID, then the protocol ID, length, and unit ID. This is all just the 2 bytes, because if you correlate with my slide, you can see that every into the Modbus TCP frame, the transaction ID is 2 bytes, protocol ID is 2 bytes. So I don't want to waste my time here. Just quickly get into the coils, okay? Because the coils is um, the coils will get activated. Basically, let me just come to this callback function, slave callback, and the slave callback will get called. Let me just take you, because here in the slave callback we are saying if we receive the value 1. Okay, so this 1 is not a value. This 1 is basically the coil's address, which starts with 1. You remember the address of a coil starts with 1. So we are writing the data 1 or 0 onto this address 1, and that will turn on and off LED. Let me quickly show you into the code. The core logic is this: like if the register address matches to 1, that's the coil address. And then if the received value is 0, then the LED which is connected to PB0 pin will light up. Oh, sorry. Yeah, turn it on. And if it's not 0, then it will set the LED, turn it on and turn. I think these labels are wrong. This will turn off LED when it's a 0. If it's not 0, that means it's a 1, and that will turn on the LED. Okay, there are a lot of moving parts into the code, but I'm sure if you understand the core logic and memory addresses, then, and if you're very good at the basic C code and programming, then you will be very easily in the position to reuse my code and implement at your site. This is very valuable skills, by the way. So let me show you how we can send this 1 and 0 data onto this coil address 1. Let's go back to this simply Modbus, and to write the data, we saw how to read, but to write, we have to click on this write button here. And you can see here the slave ID remains 1 because we are still treating our STM32 as a Modbus server. The address now we want to write is to 1. Remember, for LED, we are using coil, and coil is associated, means the starting address of the coil is 1. So we are writing the value. This is the value to write. Let's say we want to write the value 1 onto this register address, which is 1 again. Now you see the function code automatically changed to 5. It's too much, but let me just give you reference. So this is the coil address, which is 1. That is where we will be writing the data. And this is the function code I explained. When we want to write, we use the function code 5, right? Look, it used a function code 5. Earlier, when we want to read the data, the function code was, follow my mouse cursor, it was a 3, right? So now the function code is 5. So this is the request that will be sent to the STM32 microcontroller. Look at the hardware on the web camera. I hope you can see. When I click the send button, you see the LED light up because we write the value 1 onto the coil address 1. And you can see we receive coil 1 status changed 1, right? Let me select on my screen. Can you see? Let me write now, and look at this. When I sent this request, this parameter was ff into the command. So this is a command frame. So when I, let's say, want to write value 0 onto the same address is 1, coil address is 1. Now this value changed to ff. Now when I, sorry, it is 0 0, right? You have to click somewhere else so the changes will be applicable. So now this frame will be sent. So when I click on send button, look, the 0 will be sent it to the server, and look, the LED turn it off, right? Can you see? That is how we write the value 0 and 1. Okay, that's how we read and write data using the Modbus TCP protocol. I think we are running out of time, and let me just quickly come to the project presentation. So this was the project structure that we have seen. As I said, you will feel free to download the source code. I have given half of the TCP stack for free, a Modbus TCP library for free. You can make use of it, integrate it, and do it at your end. Now, I just want to summarize few things before we finish. There are two things whenever you deal with Modbus TCP. You always compare Modbus TCP with Modbus RTU. Okay, so in Modbus TCP and Modbus RTU, the significant difference in the programming point of view is, in the Modbus RTU, your last byte, last data you send is a CRC byte, cyclic redundancy check. And if you want to know, go ahead and watch the previous live streams. Here, in case of Modbus TCP, the last byte is not a CRC. We don't need CRC because Ethernet takes care of it. That's why Ethernet is considered to be much more faster communication, right? Ethernet is still very popular, very fast as compared to traditional serial protocol. Now, Modbus RTU are popular with the legacy systems and Modbus TCP as well, right? So there are a few things. If you have a question, you can ask, but I hope you have learned something out of this live stream, and I'm looking forward to take your question so that I can help you if you have any question around it. It's a big topic. I wish I could speak for another 1 or 2 hours, but I think I have to stop here. Thank you very much for being a part of this community. Yeah.
Awesome. Thanks so much, Amesh. Always good stuff. It's always a pleasure to see you work. We've got several questions in here. The first one is actually being responded to by Parth, but why don't we ask you and see what Parth says and see how the answers line up. Is Modbus code as a library, Modbus library code, is it compatible with FreeRTOS?
Oh yeah, this is a good question. See, implementation of Modbus TCP that we did today is entirely on the application layer. That means it's a part of our software, right? So you can take a FreeRTOS and you can use our library, the Modbus folder that I have shared. I will put up maybe tomorrow morning or something on a GitHub repository on David's GitHub page. You can just download that and integrate with your FreeRTOS. So what you need to do in that case is you have to port the FreeRTOS source code from the freertos.org site. Then you need to port the IO library from Viznet, and then you have to port the Modbus folder that I have shown today into the project. It's possible. And by the way, we have already covered this. So the previous live stream that we did, I think 6 months back for Modbus RTU slave, I used a FreeRTOS with it. So please go ahead. That code is already there on the Devs GitHub channel.
So the next question here from Rochelle, can we connect multiple Modbus client to Modbus server in order to read and write data?
Yeah, you can connect.
Great.
So the whole idea is just always keep in mind, whenever you're talking about Modbus TCP or Modbus protocol in general, you're talking about factories, right? Big factories. There may be 2,000-3,000 transmitters. There are 50, 60 PLCs running, and then you have a SCADA systems integrated. So there are a lot of different moving parts talking to each other, right? And Modbus in very early days is invented to meet those requirements in 19th century. Yeah.
In the 19th century.
Oh yeah, 90s. I'm sorry. I may be wrong because it's very difficult to be technically correct all the time when you are dealing with complex things. But I want to add one more interesting point. We have not used the Modbus. There's a mode that in which you can put your Modbus device to be 0. That means your Modbus device is in a broadcasting mode, right? And in industry, when you have a multiple Modbus server and treat Modbus server like the funny part, it's not a part of this. Maybe someday in the future, we will talk like how the sensors are made, right? The companies will make a sensors. They use this Modbus and they use a microcontroller, then connect the physics into the chip and then integrate the logic and act it as a Modbus server. So you can integrate it very easily because that server means that Modbus sensor could continuously broadcast the data. That answers to the question how scalable. Modbus is for scalability, reliability. Yeah. So just wanted to add quickly, like the broadcasting mode is very important. So you should know. Yeah.
I've got one more for you that we have time for today. Can you explain again, what's the purpose of the unit ID in a Modbus frame as the device already has an IP address to identify as an identifier on the network.
Okay, so basically, this is, I think the question comes, let me just use this picture here. Okay, like, it's not my picture, by the way, it's from the website called ipc2.com something, but this is a great picture. You can see the unit ID we are using, because see, how would I put things in perspective? There are two things, like in Modbus, one thing you have to understand, like, you have slave ID similar like a unit ID into Modbus TCP frame. When this top is a Modbus RTU frame and the bottom is the Modbus TCP frame. Now, it's very important when you have a multiple devices. When we say multiple devices, then we are not talking about 5 or 10 or 20 devices, right? And even the unit ID we define, because even if you have an IP address of the device, think like a sensor which is acting as a uh, Modbus TCP server. It's always good to, when you integrate into the system, like you have a system running, let's say 5,000 devices or several hundred and thousands of millions of devices, and you have to integrate something. It makes it very easy to have the unit ID along with your IP address, because IP address is also be unique to every device into the network. But I hope this answers the question. It simplify the way you configure your devices. I mean, if you are an integration engineer, maybe integrator or somebody, then I think for them it will be very good and makes their life very easy to integrate. Because see, remember, whenever you have a device which talks to the network, you have to configure this, right? The more parameter you have to configure, much easy to track the errors, or maybe if something goes wrong with that particular device or with that process into the complex chemical or pharmaceutical industry. So the answer is, with IP address, your unit ID makes more sense for the integration and configuration point of view.
Great. There's a bunch of other questions coming in, but unfortunately we're out of time. If you guys want to jump over into the DevEds Discord server, if you have not checked that out yet, I'm putting the link into the webinar chat. So there you go. If you had questions we weren't able to get to, Amesh is in there, I'm in there, a bunch of other people, Ming, Bob, Joseph, Wilson, some of the guys who are up on the screen right now. They're all participants there, and they're all experts in various areas of embedded development and IoT development. So if you have questions, please ping them in the server, and we'll get back to you. So really appreciate this, Amesh. It's very interesting, and we're looking forward to getting some additional content up, as there was even a question about whether or not there could be a follow-on event. So we'll discuss that, and until then, have a good weekend, and we'll see everybody in the server.
Yeah, happy weekend. Bye-bye.